Hello friends, welcome to Shiva Sai for You Basic Electrical YouTube channel. In this video, I am going to provide assignment week 4 solution of network analysis course, NPTEL course. Okay, so in assignment week 4, this is a second numerical. So they given two sources, one is voltage source and current source, and the elements are resistance, inductance and capacitance, and they are asked to find what is the voltage across this capacitor. So they given the capacitor voltage VC can be expressed as VC. They given some instantaneous equation, A sin 500 t plus theta and B sin 600 t plus pi, where t is in seconds, angular frequency, this is omega, that is in radians per second, and theta and pi are in radians, such that so the value of theta lies between minus pi by 2 to plus pi by 2, and pi lies from minus pi by 2 to plus pi by 2. So this is the data given, okay, and they are asking what is in this instantaneous equation, what is the value of A, what is the value of theta, what is the value of B, what is the value of pi. Okay, so to solve this numerical, okay, I am using a superposition principle, that is nothing but each source acting alone. Let me consider when only the voltage source is present in this network and the current source is open circuited. So I am opening this current source. So no current flows into the 75 ohm resistance. Only this voltage source is acting. Then if this is open circuited means then the circuit will become only one loop. Okay. Now under this condition I am finding what is voltage across this capacitor. So for that I need some basic calculation. I need XL and XC values. So that is what I am doing here. XL is J omega L. J omega L is inductance value given 28 milli. So by solving that you will get a 14J. In polar form it is 48 angle 90 degree. Similarly XC. What is XC value? 1 by J omega C. 1 divided by J omega C. 1 by J is minus J. Minus J. Omega is 500. You take 500 this one. Don't take this one because this is not acting. It is open circuited. We are considering only this voltage source. Okay. Into C, what is the capacitance value? 10 millifarad, 10 milli. So you take that one, this milli go to numerator, it becomes 1000. By doing that, you will get a 0.2 at an angle minus 90 degree. Otherwise, in rectangular form, it is minus 0.2 J. Okay. So now, I want to find voltage across this capacitor. You know the supply voltage. These two are connected in series. When the current source is open circuited, these two are in series. Apply voltage division rule. What is voltage across capacitor? Supply voltage into same resistor reactance divided by sum of the reactance. Just apply voltage division rule. What I written here is, that is voltage division rule. Okay. So the pen is not writing. Okay, fine. Somewhat it is writing. So voltage division rule. Okay. This concept is voltage division rule. What is voltage? 20 sin 500 t into, okay, I want to find voltage across this capacitor. Take XC. XC divided by XL plus XC. So 20 sin 500 t into, what is XC? Minus 0.2 J. And what is XL? 14J plus, and what is the value of XC? Minus 0.2J. So do this, you will get some value, you will get some constant, you will get, and that constant multiplied by this 20, then you will get a value this much, minus 0.2898. I request the viewers has to recalculate once again and then confirm whether you get same value or not. Okay, into sin 500t. Okay. See in what format they have mentioned here, in sine form only. The same, whatever the answer you got, you can convert that into cos form. So in main NPTEL exam, so the same question may repeat in exam also, but they will give, instead of sine they will give cos. Means whatever initially you got, later you can convert sine to cos by using the relation. Minus sine theta is cos theta plus 90. Okay, by using this relation, the same answer I am converted like this. Okay, so 0.2895 cos 500t plus 90 degree. But this one is not needed. I am going to select this one. Okay, this is needed. Okay, this minus 0.2895, that indicates A value, and this is omega value plus theta. We don't have angle, so we can write theta is 0 degree. Okay, got it? So this is the voltage across capacitor when voltage source is acting alone. Next, when only the current source is present, the voltage source is short circuited. Now, I am acting, considering this current source is present, then voltage source should be short circuited. Then how the circuit looks? This current source, resistance, capacitance, and then inductance. This inductance and capacitance will act like a parallel. So from that I am finding effective reactance. Okay, and this is a current source. Now whatever current flowing in 75 ohm, same current is circulating in this loop. Okay, so before calculating the voltage, I want to find effective reactance of this part. Okay, so that is written here when voltage source is short circuited. At that condition XL. Now XL formula is what? J omega L. Now you take omega value, this one 600. Don't take this one. Okay, 600. L is 28 milli. So from that we got XL value 16.8 J. Then XC. 1 by j omega c. 1 by j is minus j. So 600 is the frequency and 10 millifarads. Milli is shifted to right top. Okay, then by simplifying this, you get minus 0.1667 j. Then XL and XC. See, when voltage source becomes short circuited, the inductor and capacitor are in parallel. So those reactances are in unit is in ohms. So when two reactants are in parallel, we can write like this: XL XC divided by XL plus XC. Enter XL value and XC value, XL and XC. By simplifying, you will get the net value is XL plus XC is minus 0.1683 j. Now, what is voltage across capacitor? Okay, current into parallel combination. See, what is current flowing here? The same, 5 sin 600t only. Okay, whatever current flowing is, whatever the voltage in this capacitor, same voltage will be in this inductor, because both are in parallel. In parallel, voltage should be same. Okay, because when current source is acting, voltage source is short circuited. So this two will be in parallel, voltage should be same. So if I find what is voltage in this branch, same voltage will be in this part. So both are in parallel. So I am taking that effective reactance. Okay. So therefore, voltage across capacitor is current 5 sin 600t into XL parallel XC. So what is the value got that you mentioned? This into 5, you get minus j 0.8418 sin 600t. Okay. So now this becomes minus 0.8418 sin 600. Whenever minus j is there, you can write 90 degree, minus 90 degree, plus j plus 90 degree. Means here in electrical, the j indicates the phasor rotates in anti-clockwise direction by 90 degree. Minus j indicates phasor rotates in clockwise direction by 90 degree. Okay, but it is standard and universally adopted all over the world. The phasor should be always rotated in anti-clockwise direction. Okay, so we got voltage across capacitor like this. Now the total voltage is voltage across capacitor when voltage source is acting alone is this much, plus voltage across capacitor when current source is acting alone is this much. So we got entire equation. So this is A value, okay, and this is theta value is 0, and this is B value 0.888418, and this is pi value. Okay, I return 90 degree, but you should mention that in terms of radians. 90 degree is called what? Pi by 2 radians. What is pi by 2 in terms of numerical value? 1.57 radian. Okay, do this in calculator, you will get minus 1.57. You are recommended to enter this value in the answer, minus 1.57 radian. Okay, actually it is pi by 2 radian only. Pi by 2 value, simplified value is 1.57. I hope you understood. So whatever I am explaining here, it is a correct method of solving. So you just analyze whether I have taken the same values asked in the numerical. Okay, if there is any slight changes in the numerical, so their answers will changes accordingly. Okay, so before entering the answers in the assignment, you should cross check once again, you should resolve once again, then go ahead. Okay, if any mistakes is happen, I am not responsible. Okay, got it? Okay, understood? For example, sometimes I won't make mistakes, sometimes I may made. See here, 500 is there. In place of 500, suppose if mistakenly if I take 600 here, so that then you will get one question is wrong, means everything will be wrong. Okay, in numericals. If first step is wrong, everything will be wrong. So that's why you just confirm that whether I taken same assignment data or not, according to that I am solving or not, just go through that. Okay, in main exam you may get same numerical, but they will change the values in terms of cost term. So by knowing the trigonometric relations, we can convert sine to cos, cos to sine accordingly. Okay, so thanks for watching. So again after some time I will upload question number 3. So have a nice day, take care.